see question number 30 from the book. Okay, question number 30 is x squared and then times cosine of x dx. Okay guys, so to find out this derivative, again we can always try the table method if it works. If it does not work, then we will try the substitution method, the integration by parts formula. Okay, so here what is the what is the formula to try the u function? IL a t e. Is there inverse? No. Is there a log? No. If there is a polynomial function, algebraic function, yes. So this should be u, this should be v. Okay, so u v. Oh yeah, this will work because you see that when you find the derivative, it is 2x and derivative is 2 and then 0, right? So what is the derivative of entire derivative of cosine x? So this is cosine of x. Entire derivative of cosine of x is sine x, right? Entire derivative of sine x is negative cosine of x. Entire derivative of negative cosine x is negative sine x. Okay, so you do, this is the product, positive multiplication, this is negative multiplication, this is positive multiplication. So what can you write then? Your final answer is x squared times cosine of x dx is x squared times sine x, x squared times sine x, and then 2x. So it should be minus because the negative multiplication, but there is another minus, so it will be plus 2x cosine of x, right? And this is minus, right? Minus 2 sine x. That's what you get. That is the final answer. Okay guys, so I want to do number 34 here. Question number 34. Question number 34. It has integral of e to the 4x times cosine 2x dx. Okay, you see that if you do the table method, then it will never end, right? Whatever you do, u and v. But first of all, let us try which one should be u, which one should be v. Okay, let us try that one. Is there inverse function? No. Is there a logarithmic function? No. Is there an algebraic function? No. If there is a trig function, yes. So it is u. This is, the other one is v, right? So if you find out the derivative of cosine 2x, it will never go to 0. It will be cosine sine, cosine sine, cosine sine. So similarly, if you find out the entire derivative of e, it will be e to the 4x, e to the 4x, e to the 4x, like that. Okay, so it will never terminate. So we need to do the formula. What is the formula again? The formula of integral of u times v dx is equals to u integral of v dx, right, minus derivative of u times integral of v dx, and there is a dx outside. Okay, so let us try that. So this is equals to, that function is equals, let us denote this by I and then write I equals, so that I don't need to copy that whole thing again, right? So what do you get? You get basically, you get, let me use this color. So u is cosine 2x. Integral of v. What is the integral of e to the 4x? It is the e to the 4x over 4 minus integral derivative of u. What is the derivative of cosine 2x? It is negative sine 2x times 2. That is the derivative of cosine 2x. Times, what is the integral of v? It is again e to the 4x over 4 and then dx. You see that? Let us write down in nice format. So you get 1/4 e to the 4x cosine 2x. Okay, and then minus minus will be plus. I got 1/2 because there is 2. You see that? There is 2 and then there is 4 in the denominator. If I cancel that out, I get 1/2. And then you can write e to the 4x times sine 2x and then dx. Okay guys, that's what you get. All right, so basically there is again the product. You see that? There is again the product. So we will do trig function u. Okay, I will do trig function u, and then the exponential function v again. So let me write down equals to 1/4 e to the 4x, and then cosine 2x, I copied that, the first term, cosine 2x, I copied that, and then there is plus, I'm writing 1/2. I'm using the integration by parts again on the second integral, right? So it is u is sine 2x, so u is sine 2x, right? And then integral of v is again e to the 4x over 4, you see that, minus derivative of u. What is the integral? Derivative of u is cosine 2x times 2 times integral of v is e to the 4x over 4 again. Okay, now what do we have? So we assume that the question is I, right? So we have I equals to, so that is I equals to 1/4 e to the 4x times cosine 2x. Now plus, let me distribute that. I get 1/8 e to the 4x times sine 2x minus 1/8 integral e to the 4x. Oh, not 1/8. It will be 1 over because this is, you see that I forgot to cancel that. That will be 2. 1/4. That 8 will be 1 over, because there is 2 and there will be 1/2, right? So that will be 1/4. You see that? That will be 1 over. I'm sorry. This will be 1/4. E to the 4x times cosine of 2x. This is weird, right? Because you see that on the left side we started with I, but we got this term is basically I. That's what we started with. That is another I, right? That is also I. Now you see that negative 1/4 I on the right side. So what I'm going to do is I'm adding 1/4 I from both sides. Plus 1/4 I plus 1/4 I. You cancel that out. 1/4 I and 1/4 I. What do you get? So I plus 1/4 I is how much? I plus 1/4 I is equals to, you get 1/4 e to the 4x cosine of 2x, right? And then plus 1/8 e to the 4x sine 2x. That's what you get. Okay. So what is the left side though? That is, it is 1i plus 1/4 I will be 5/4 I. 5/4 I is equals to 1/4 e to the 4x cosine of 2x plus 1/8 e to the 4x sine 2x, right? Therefore I is equals to, you need to multiply both sides by 4/5 or divide by 5/4. It's the same thing, okay? I equals to, I am multiplying by what? I am multiplying by 4/5. That will cancel out 4/5. So 1/5, you see that? 1/5 e to the 4x cosine 2x, okay? Plus 4/5. 5 over multiplying by 4/5. So what do you get? So you get 1/10. If you multiply by 4/5, 4/5 here and then 4/5 here, what do you get? 1/10, right? That will be 1/10 e to the 4x and then sine 2x. You see that? So this type of problem, if you have the combined product of exponential and trig function, you will never terminate by if you use the table. That's why what you need to do is remember that you will have to find the you will have to do the integration by parts twice, and then on the right hand side you will get the thing that you started with and bring that to the left and then simplify. Okay, if you want to further simplify this, what do you get? You get, let me make the same denominator and then take e to the 4x out. Okay, so you can write e to the 4x and then you can write 1/5 cosine 2x plus 1 over 10, and then you get sine 2x, right? Plus c is there. I forgot to write that one. So what do you think if I make the same denominator? You can write e to the 4x over 10. So that should be, let me write down 10 here, and then if you make the 10 on the bottom, so what do you need? You need to multiply by 2 by 2, right? Here, you see that? 2 by 2. If you do that, then you will get 2 cosine 2x plus sine 2x, and then plus c. That's what you get. 2 cosine 2x plus sine 2x plus c. But there is a direct formula, because you see that from next time, if you don't have to do all these like that. So if you have, so the formula is this: if you have integral of this type, okay, so if you have, the formula is, if you have e to the ax sine bx dx, then there is one formula. And then if you have number 1, and number 2 is, if you have like e to the ax and then cosine bx dx, then the formula is a little bit, it is similar formula but a little bit different. So that formula for e to the ax sine bx will be e to the ax over a square plus b square, and then you write a sine bx for the sine, okay, minus b cosine bx, and then plus c. But if there is e to the ax times cosine bx dx, then it will be e to the ax over a square plus b square, right? And then it will be a cosine, so a cosine bx plus b sine bx plus c. You see that? If you use this formula, the second formula will be applied to here, right? You will get e to the 4x over a square is, a is 4, b is 2, that will be 20. E to the 4x over 20, and then a is 4, okay, cosine 2x plus 2 sine 2x. But if you take 2 out, you will get e to the 4x over 10. So it is the same thing, okay? But you can apply, you will get exactly the same answer if you use that formula directly. Alright guys, so from next time you can use this formula, but you need to know how did we derive this formula, okay? If you have e to the 4x times cosine 2x dx, we need to do multiplication by integration by parts twice, okay? So, or the multiplication rule of the integration twice. Alright guys, so let me do some more example there. So the next example I want to do is, I want to do question number 48 from the book. Question number 48. It says it is a definite integral 0 to 1 x, and then sine inverse x square, and then dx. Okay guys, so how do I do this? How do I find the integral of this? That is the next question. So for here, you can do the u substitution first. What is the u substitution? You should do set x squared equals to u. Then what do you get? You get 2x dx will be du. So it will be x dx will be 1/2 du, right? And do you want to change the limit? Also, when x is 0, what will u? When x equals to 0, when x is 0, so when x equals to 0, then u will be what? U will be 0 as well. But when x equals to 1, then u will be 1 as well, because if you plug in x equals to 0, this is the limit for x. I want to write limit for u, right? Then u is also 1. So basically what you get, this integral, let us denote this by I equals to. So I equals to, you still get 0 to 1, x dx will be du over 2, it will be sine inverse u times 1 over u, 1 over 2 du. So sine inverse times 1 over 2 du. You see that? Let me pull that here. 1 over 2, 0 to 1, sine inverse u, and then du. Okay, so how do I do this? Okay, I will do another example that has similar thing there. So how do I do this one? So we don't know what is the antiderivative of sine inverse u. We know what is the derivative of sine inverse u. It will be 1 over under the root 1 minus u square. But what is the antiderivative of sine inverse u? That is the question. Okay, so this is a different type of problem. Okay, so what we need to do for this one is, again, you see that we should use the product rule. What is the product though? There is only one term, sine inverse u, but you can always do 1 times, right? Now we need to do the ILAT formula. Inverse should be u, so this should be u function. You see that? This is u function, and 1 should be v, right? Now let us use the formula. There is like 1/2 is outside on bracket, so u integral of v, that will be sine inverse u times integral of 1 is also u, because v is 1, integral of 1 is u, minus derivative of that. What do you think? What is the derivative of that one? That will be integral, derivative of that is 1 over root under 1 minus u square, right? And integral of v is again u. You see that? By the way, that one. And then du, the limit is 0 to 1. These limits are for u. Okay, guys? So what do you think? What is the integral of that? You can again do the u substitution, another u substitution there. And then the derivative will be the top, right? So you can do that way. Okay, so let us try. I want to do y substitution. Okay, it is same, but since there is u already, so I want to do y substitution. What do you think? That is 1/2, and then u times sine inverse u, u times sine inverse u, right? Minus. So let us do the y substitution. What do you think that will be? That will be set. Let me write down here. Okay, let me use different color. So set 1 minus u square will be y. Then negative 2u du will be dy. So what do you get? You get basically, I will come back to u later. So u du, that is u du, will be negative 1/2 dy, right? So what do you get here? It will be like 1/2 dy over root y. All right, so that will become, let me use different color for that. So what I'm going to do is I will come back to u later, so I want to keep that same limit. Okay, so what I'm going to do here is I will get integral negative 1/2 dy over root under y. Okay, so what I'm going to do is 0 to 1. I'm taking 0 to 1 for u, so these are not for limit for y. Okay, I'm coming back to u later. So what do you get there then? So that is 1/2, and then u sine inverse u minus, oh, it will be plus 1/2, because you see that will be like that, and then move that to the top, y to the negative 1/2 dy, 0 to 1. So what do you get? You get 1/2, and then u sine inverse u, I will plug in the limit at the same time for all of them, plus 1/2. What is the integral of that? That will be y to the negative 1/2 plus 1 will be y to the positive 1/2 over positive 1/2. You see that positive 1/2 and positive 1/2 cancel out. That was in the top, that was in the denominator. And then 0 to 1. So I need to plot. What I need to do is I need to do 1/2 there. Okay, and then how much is that? That will be u sine inverse u plus, what is y? Y is 1 minus u square. So I will write root under 1 minus u square, 0 to 1. Because you see that y root y, this is y to the 1/2 is root y, root under 1 minus u square. Now plug in the limits. what do you get? If you plug in the limit 1, you will get u sine inverse 1 is pi half, right? So 1 half, okay, 1 times pi half plus, if you plug in 1, you will get 0, minus. Now plug in 0, that will be 0, and then minus, this will be 1. So what is the final answer then? You will get 1 half, so pi half minus 1. That will be pi minus 1 half. You see that? If you distribute that, you get, that will be pi over 4, right? Pi over 4 minus 1 half. Pi over 4 minus 1 half is the final answer. So do you guys know how to find the antiderivative of natural log of x? We know that the derivative of natural log of x is equals to 1 over x, right? But what is the function whose antiderivative is natural log of x? Okay, so how do I find out this? That is the thing that I am going to show you really quickly here. So you see that we don't have any formula for this, right? There is only one term, but if there is only one term there, you can always use integration by parts, no problem, because you can think 1 times that and then use the ILATE. So there is no inverse, there is log, so it should be u. So this should be u and this should be v, right? So if you use that, what is the formula for that? It is integral of u times v dx is equals to, the formula is u integral of v minus integral of derivative of u integral of v and then dx last. So this is the formula, we know that, right? So let us use that formula. So you get basically so u integral of v, that is natural log of x, times integral of 1 is x minus derivative of u is 1 over x, right? That is 1 over x, derivative of natural log of x, derivative of u, times integral of v is again x and then dx. See that? So what do you get? X natural log of x minus that x and x cancel out, right? What are you left with? That is 1. So what is the integral of 1 is x. That is the function whose derivative will be natural log of x, or the integral of natural log of x is that. Okay, if you want to find out the derivative of this, you must get natural log of x, right? Because you will have to use the product rule here to find out the derivative. Okay, and then you will get natural log of x. Therefore, what is the formula then? Natural log of x dx is x natural log of x minus x. That is another formula. Okay, you can apply this formula in the future. Okay guys, so this is how you find out the antiderivative of natural log of x. And you know, sometimes if there is only one term left and if you don't know what is the integral, you can use the product rule or the integration by parts, saying that that function is u or v whatever and 1 is the another function. So you can take u and v, u times v as one of the function as 1. Okay guys, so integral x to the 5th times e to the x square dx. Okay, so how do you want to do that? Is what I want to do is, you see that there is exponent of exponent. So I want to use substitution first for x squared to make this, get rid of exponent of the exponent, and then I will come back to the integration by parts. Okay, set x squared equals to u, then 2x dx will be du. So x dx will be 1/2 du, right? So you can write this as, so the integral I, let us denote that by I. So I will be equals to what? I'm naming this by I so that I don't need to write that again. Okay, so I is equals, so you can write x to the 4 times e to the x squared times x dx. I'm just writing x to the 5 as x to the 4 times x, so that I can write that 1/2 du there. So it will be, let me write in using u. You write u square, because u is x squared, times e to the u times 1/2 du. So this will be what? 1/2 u squared du. Oh, e to the u du times e to the u du. Okay, so we know that formula, right? Or you can basically, so you see that ILATE if there is an inverse function, that should be u, because that's the product, right? That is the product. So what should be u, what should be v? So let us find out that. If there is a log function, that should be u. If there is an algebraic function, there is u. This is algebraic. U square is algebraic. So that should be u, this should be v. Let's make a table, because this will go down to 0, right? That's why. Let's make the table there. So you can write u, v. So this is u square. Let me use different color there. U square, and then e to the u. So what is the derivative of u square? Twice u. Derivative of twice u. 2. Derivative of 2, 0. Entire derivative of e to the u. E to the u. E to the u. E to the u. Right. So just skip the first v and then go positive multiplication, negative multiplication, positive multiplication. So what do you get then? So you basically get I is equals to 1/2 is there, u squared times e to the u squared times e to the u, minus, because that's a negative multiplication, 2u times e to the u, 2u times e to the u, and then plus 2 times e to the u, right? So what do you get then? So you get basically e to the u over 2, e to the u over 2, right? You get u square minus 2u plus 2. Now what is u though? U is x squared. Let's plug in that. 1/2 e to the x squared, x to the 4 minus 2x squared plus 2. That is the final answer. Okay, so this is the end of the chapter 8.2. Okay guys, thank you.